Okay, Assalamualaikum. Okay, Assalamualaikum and good morning. Hello, Assalamualaikum.
Salam.
Okay. So, you all can hear me clearly?
Yes, we can
Okay.
hear you clearly.
Okay. Okay, actually our meeting is quite simple because the teaching material is uploaded in the Facebook group. So, in the meeting here, I just would like to get some feedback from you all. Maybe some questions or anything that you want to ask regarding the course. Okay, for this topic, actually, for stress in soil mass, okay. Okay, this topic is regarding how to find the increase in stress due to surcharge or loading. So in this course, we learn how to calculate the increase in stress due to point load, line load, and so on. Okay. Okay. I hope you can see the PDF file. Okay. Yeah, I think you can look at my teaching video in the Facebook group. I explain in detail there, but here I just want to just go over it quickly. Okay, so we are going to use this equation quite a lot. If you were to calculate the minor and principal stress. You should learn this in your strength of material. Okay, how to get the sigma 1, how to get the sigma 3, and also to get the angle of inclination. So there are equation here like major principal stress and minor principal stress here. So we can use it to calculate the sigma 1 and sigma 3. Okay, here is the location of sigma 3 and this is the location of sigma 1. So there's several methods that we can use to calculate sigma 1 and sigma 3. One by using the equation, and second by using the pole method. So for example, in this one, we need to calculate the principal stress for a given soil element under normal and shear stresses. Okay, I think you can also look at your PDF file. And there is also a pole method to find stress along the plane. So this will be your, I would say, review for your strength of material class actually. Yeah, this is how to use the pole method. And then we look at the point load. Point load is like uh, a column. It could be a column, or it could be a pole. It's just a single point where the area, cross-sectional area, is so small that we can assume it is just a point. So if we have a vertical point, in real life, it could be like maybe the a pole for advertisement, where we can see advertisement outside. There are two poles, so we can consider that as a point load. So to calculate it, we can to calculate the increase in stress, we can use this equation. And at the end, we can use to find I using this table. Okay. And also we can use this figure to calculate the increase in stress due to the point load. Okay, so example given, I think it would be a straightforward. If you read it, I believe that you can figure it out, how to calculate it. And then we have a vertical line load. Here the difference between the point load and line load is that the line load per unit length, it is a per unit length, meaning that it is like a wall. A wall is considered a line load. It's not like a pole. It's there is a per meter length. Even though if you look there, it is like a point load, but actually it's per meter length. So the same thing here, we are given the equation to calculate the increase in stress due to the line load. So these are the equation given, and the same thing we also given the table to calculate the increase in stress. So we can just use the table, for example, table 10.2. And we can also use the figure 10.10 here to calculate the increase in stress. Okay. Example also given. And then here is a stress caused by horizontal line load. Here the load is like this one, horizontal per meter length. So this one, to imagine in a real world situation, it could be like a force, a lateral force or horizontal force applied to a wall. Maybe you put, I don't know, some support to the wall at the bottom, and then it could be the lateral or horizontal line load. So the same thing, we are given the equation. We can just use this equation, and by using this equation, or to make it simple, using a table, so we can calculate the initial stress increase due to horizontal line load. So if you look the whole chapter, it is about the same thing, where you use the equation and as well as the table and figure to find the uh, increase in stress due to various type of loading. And this one for, let's say the load is vertical strip load. So when they call it strip, not line, strip meaning that there is a width, for example, if the wall, if the width is considerable, big enough, then we can use it, we can consider it. For example, like this one. Let's say the width of the wall is big here, big, and per meter, per unit area, load per unit area, because it has some value B which is considerable. So then if the load is like that, let's say we have a thick wall, then we can consider it as a strip load. So the same thing, what you need to understand when you want to use the equation, look at the location of Z here, whether it is in the middle or it is at the corner. Like this one, we need to use the equation, make sure the point or the solid element is at the middle of the width of the load. So then we can use this equation, long equation. Definitely we are going to use the table much easier. So we can use this table 10.4 to calculate the increase in vertical stress due to the strip load. We need to find B given here. B given, normally given. So by using that value, we can use this table and then find the increase in vertical stress. The same thing, they should give the figure also, like this one. So we can look at the figure and find, at the end we calculate the increase in vertical stress. Okay. Example also given. You can look at the example and understand better. Okay, then we look at vertical loading on an infinite strip, meaning that now we have a finite, infinite vertical loading, increasing. Here the point is linearly increasing, meaning that it's not well distributed. The load is like this one. I say this, the width of the wall maybe not the, the loading is not well distributed, but at this corner, for example, we have no load, and at the other end of B, we have a much higher load. So we can use the equation given, this equation, or we can use the table here. So the same thing. What you need to know is what type of loading, from what type of loading, find which the right equation to use, also the right table and the right figure to use. So you will be in the right track. Example is given so you can understand it better. And for 10.9, we need to find the increase in stress due to embankment loading. Embankment loading, so embankment is like this one. This is half of the embankment. So we have another half symmetrical, like this one. So we just consider half of the embankment. Embankment in bahasa is benteng. For example, we want to build a highway on top of the embankment here, on top of here. So we need to build embankment, so that the soil is stable. So to calculate the increase in stress due to embankment, for example, what is the stress at this point, for example, due to the weight of the embankment, we can use the equation given here. For example, 10.20 equation. So we can use this equation, and also we can use also the figure given here to find the I2 here. And also B2. B2 and Z normally we given, so we can get the I2. And also the sample problem to make it clear how to calculate it. Yeah, it gives you the sample problem here. So you can look at this one. And then after that, we learn how to calculate the increase in stress due to the uniformly loaded circular area. Meaning the area is circular. It's like we, in real life, let's say we want to calculate, let's say we put a water tank on top of a soil. Then we want to know maybe at 5 meters below the water tank, how much is the increase due to the loading of the water tank. Then we can use this equation. So the equation is like this one. But still we need to know where is the reference point. So the reference point is exactly at the center of the circular area. So this is the point of interest. A is a point of interest where we want to calculate the increase in stress. Okay, so let's say it is off somewhere here. So we cannot use this one, the equation given. So this one is for exactly in the middle of the circular area. Okay, so it's also given the table to calculate the increase in stress. And then after that, let's say this one, let's say the point of interest, let's say this is the location of soil where we want to find the increase in stress, which is not in the middle of the circular area. So we can use this one, the table here, to calculate the increase in stress, which in terms of B prime and A prime. So A and B prime is given here. This is the equation. So we need to find the A and B, and also then we can calculate the increase in stress. Okay. Also, it is given the plot so that we can find the increase in stress here. Okay. Also, example is given. And then after that, we learn how to calculate the vertical stress or increase in vertical stress due to rectangularly loaded area. Meaning that the loading in the shape of rectangle here. So this is a cross section of the loading. The shape is rectangle, so it is like a building. A normal building is a rectangle shape. So here very important also to look at the reference point. Here is at the corner. This one is at the corner. So make sure we, if we were to use this equation, make sure the location of the soil element below the corner of the rectangular. That is very important. Then we can use this equation and also find the I3 here. I3 because it is in the equation here. So we need to find I3. We know Q, so we can calculate the increase in stress. So also given here how to find the I3 with a known M and N. Actually M and N we calculate by using the equation here. M equal to B over Z, N equal to L over Z. So it's given here L and B. Which one is B and which one is L? Depend. Normally L is greater than B. If they are equal, then B and L is the same. Normally we denote L when it is bigger than B. Okay. So we can use the table here and also the figure here to find the I3 known M and N. This is N, this value is N. This value is M, so we can find the I3. Then if we know I3, then we can calculate the increase in vertical stress. Okay, let's say we have the location is not exactly at the corner. At the corner, we can straightforward using the whole area here. But the thing is, the location of soil where we want to find the increase in stress, let's say it is not at the corner. It can be either corner, not at the corner. So we need to make it at the corner so that we can calculate the increase in stress. So since it is not in the corner, we divide the area here into 4. Make sure that it is at the corner. Point must be at the corner. So we have like 4 parts of loading. Then we need to calculate each. Every one, area 1, area 2, area 3, and area 4. Then we add up. So then we can get the right increase in vertical stress for the whole area here. So we need to add. Yeah, so we need to add. Oops. Yeah, this is the one. So we need to add the I3. One, area 1, area 2, area 3, and area 4. If we were to use this one, where I think it is at the center of the rectangular, we can use this one. So very important for you to look at what is the reference for the location of the stress, whether it is at the middle or at the corner of the rectangle. So we use the right equation. Okay. Also for the reference at the center of the rectangle, also given the table to get the I4 with a known M1 and N1. So there is problem or example given here. It is nice for you to read and understand it. So it's quite straightforward. And then another method is to use the influence chart. Okay, to use, and we call it a Newmark chart. So this is the Newmark chart with the influence value 0.005. So it is also given the distance A and B. Okay. So to calculate it, you just follow the procedure here. First, you find the depth Z, and then the scale AB, the length of AB is the depth of Z. Make sure the depth is the AB. And then we just place the plan on the influence chart in such a way that the point below is at the center of the chart. And then we can count the element. And then we use this equation. Okay, here is a given example. Okay, for example, footing here, footing size 3 by 3 meter. Okay, the load is 660 kilonewton. Okay, let's say the depth is 3 meter. So the first one say we need to find the depth. The depth is 3 meter. And then the second rule say 3 meter depth is equal to this AB length. Okay, so AB, distance AB is 3 meter. And the footing size also 3 meter by 3 meter. So we have like a 3 meter by 3 meter. The length is like this one. 3 meter is this length. So we get this plan. 3 meter by 3 meter, which is the length 3 meter equal to the length of AB. AB is the 3 meter because the depth is 3 meter. Okay, so what we need to do now, let's say we want to find at A. What is the stress 3 meter below the footing at point A? So what we need to do here, we need to locate point A at the center of the graph here. So that's why we have A here at the center. Now, the next step is to calculate the number of elements inside this block or area. So we calculate one by one. Let's say 1, 2, 3. And then some, let's say like this one, maybe half. So we need to use visual observation. So we calculate by using our, by looking at the area there. Some, if full, we say 1. Let's say a half, we say a half element, for example, half. So we calculate the number of elements inside the area. So at the end, we use the equation here. M is the number of element. Q we know. Q is a charge, which is 660 kilonewton over the area, which is 3 meter by 3 meter. And IV value is 0.005. So we can calculate the increase in stress. So this one is quite simple. And many people use a Newmark method instead of the calculation. Because if we were to calculate using equation, we have to make this one at the corner A, so we have a two area. We have to separate here. We have area 1 and area 2. We have to make sure point A at the corner of the area. So we need to divide it into 2. But if we use this new mark, we don't need to. We can just uh, locate the point A at the center of the graph or chart. So example also given, so it's quite straightforward. So that is about chapter 10. Okay, I think that would be my brief explanation. The rest you can watch the video, and then next week I already upload the chapter 12, strength of material, for this week material. So it is up to you to watch the video, understand it, and learn about chapter 12, which is strength of material. It is important because you also need to do the lab test, which is direct shear stress, and also triaxial test, which is in the chapter 12, strength of material, strength of soil, shear strength of soil. So I also uploaded demo of those lab tests, so you can watch in the Facebook group. Okay, and yeah, as far as the lab test, I already contacted the technician, and they said they already given you in groups, and also there is a schedule for you to do and run the test. Each group just 1 day. So for 1 day, you will need to, for each group, you need to do the test for 3 tests. So we try to minimize the contact hour face to face since the COVID-19. So each group 1 day, so you need to divide it among the members, so that who is going to do the direct shear, and who is going to do the triaxial, and who is going to do consolidation. So fortunately, or maybe unfortunately, because we try to reduce the contact hour, you will do the direct shear test, but you will be explained, and the technician will run the test for triaxial and also consolidation. So they will give you the data for you to write a report. So yeah, they will give the data so that you can write the report. So so you will be handled by technicians in the labs. So and they promised me to give me the schedule as well as the group today, but I still haven't received it yet. I will upload it in the Facebook then when I receive it. Yeah, I think that is about the lab test. Okay, the rest is, I would say, I hope you already do the assignment 1 individually. If you have any question, or you can ask me. If not, then yeah, that would be my brief meeting for today. Okay, any question or anything that you want to raise? Or you all fall into sleep already?
Oh, Doktor.
Huh? Okay. Is there any question? If you have a question, you may also post under the comment in the video there. Sometimes maybe you get confused somewhere, then you can just do comment there. Okay. 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 I will post back the attendant. Okay. Then maybe I will post it until 4. See, I don't know whether you can manage to scan it or not. But not if not, then what to do? Then that is not our fault. Okay. Uh, let me. Okay, then you can try to scan. See whether it works. Okay, if you don't have any question, then I can leave you here, or you can, I don't know, you can try again to scan the attendance. Is that okay like that?
Doktor, the system still down lah.
Still down? Okay, that's okay. I will leave. Okay, I will leave this attendant until 4. Maybe you try 10 minutes before 4, something like that. I don't know. Maybe it works again.
Okay, Doktor.
So is that okay if we stop our meeting here? Just leave the attendant here. Okay, yeah. Okay. Okay, then we see again next week. If anything, I will either I will either WhatsApp or put something in the Facebook group. Okay, then see you then next week, insyaAllah.
Doktor.
Yeah.
Atau doktor terus download saja attendance kami dalam MS Team ini. Siapa yang ada join, doktor terus download je lah dalam sini.
Download what?
Attendance.
Download attendance.
How to do it? To download. What do you mean?
MS Team. Siapa yang who join this meeting, then you can direct download the attendance through the MS Team.
Okay, yeah. Okay. Let me see. Okay. I will get your name through the MS Team then. Okay. Okay, or you can just, I think you can chat, right? Type your metric ID, to be sure.
you. You